Hi ladies and gentlemen, this is Mr. Green and this is another in my AP statistics videos that I wanted to go over with you guys. Right now we are finishing or starting with the chi-squared conversation, and I'll get into what chi-squared is in just a second. That's 10.1. This is the last topic before we get into test prep type things, and then we'll be into the final exam. So we're making a very quick end to this unit, okay? Or not necessarily this unit, but I mean to this course. So be aware, we're going to end early, and we will be prepared to take the test as soon as we possibly can. This is the last topic that we'll take up, chi-squared. Okay? So make certain you're out there looking at those due dates. We don't want any zeros hanging on out there, and we want to be working on our test prep after we get through with this. So make certain you're all caught up here real quickly. Okay? Well, chi-squared is one of the topics that is in the AP statistical inference type area. It's this goodness of fit type of information. Okay? What is chi-squared? Chi-square is when you're looking at parameters of some information, not necessarily at statistical data, but at parameters. And you're trying to see if those parameters meet what you expect them to meet. Okay? So to do that, what we're going to do is we're going to calculate a chi-square number, and it's going to be the observed minus the expected. And we're going to get rid of any negative numbers by squaring it and then dividing by the expected number, and that will give us a number. And it'll always be a positive number. Okay? What we are doing is conducting a hypothesis test. So there will be an H0 and there will be an HA that you're going to need to come up with every single time. Okay? And you'll need to make certain that it meets certain issues to make certain that it is a valid information for us to be looking at. Okay? So we're going to look at data that is basically the counting, the number of times this occurs. And we're going to break it down into some categories. Okay, the chi-square distribution, it's different for every degree of freedom. So what you have to look at is you have to be able to calculate the degree of freedom. Typically what you're going to do for a one-way table is you're going to take the number of possible outcomes or categories that you have, subtract one from it, and that'll give you a degree of freedom. What you're looking at on the chi-square is the area underneath the curve, but it's a very much skewed to the right type of a curve. Okay, and this is different for different values of different values of degree of freedom. So this one might be 10 and this one might be 1. Okay, so you're looking at some things that are going to be kind of different there. Okay, and then we'll calculate that chi-square information. Chi-square distribution depends upon that degree of freedom. Area under the chi-square curve has been calculated and organized by degrees of freedom in a chi-square table here. But you can also use the chi-square CDF on your calculator. Where do you find that? Look under distributions. If you go to distributions, mine was under distribution C, and we'll get to that in just a few minutes. I'm going to start up my calculator right now so it'll be there when we get to it. Okay? So going forward. So for K categories, our H0 or hypothesis or null hypothesis is that the proportion in each category is going to be equal to 1 over K. It's going to be equal. That's what our null hypothesis is, that the expected proportions in all the categories are equal. Our alternative hypothesis is that the proportions in at least one category aren't equal. I didn't say all the categories aren't equal. I said at least one category is not equal, not all. So for the chi-square test to be valid, all the expected frequencies must be at least 5. That's an important number to remember. Be easy for us to calculate it, so we'll get to that in just a minute. To test and calculate chi-square and compare to the chi-square distribution table with k minus 1 degrees of freedom, and you're always looking for the upper tail area. You're always looking for this area out here to the right. Okay? That's what you're looking for. The upper tail area is the p-value of the test. If you reject H0, examine the components to determine which categories are the most different from expected. Okay? We'll do some of this. We're going to use the expected proportions to calculate the expected number in each category. Remember, it's not to round the expected frequencies too early and calculate the chi-square statistics as you would the proportions are equal. This is when you have unequal proportions, okay? For chi-square, the test to be valid, all expected values frequencies must be greater than 5. So, here we go. We're asked to look at this table here, and they're wanting to know, are the number of runners going by your house the same every single day? You've got this table, and it gives you the number of runners going by your house every single day. There's 7 days, so you would expect the number, expected number, to be PECT, expected number, to be 80 divided by 7. Well, this works out to be what, 14 point something? Looking real quickly. 80 divided by 7 gives you 11.42, 11.43. 11.43. Okay? So here's what we're going to do. We're going to actually calculate the expected number for each one of these. 11.43. We're going to take this number minus 11.43. We're going to square that difference. And then we're going to divide by 11.43. It's really not that difficult to do. When we do that, here's what we got. Here are my values. 17, 18, 9, 6, 7, 11. Expected values. If I take it, subtract it, square it, divide it by 11.43, these are the chi-square values I get right here. I sum them all up, I get 10.31. With degrees of freedom of 6, how did I get 6? 7 minus 1. 6 degrees of freedom. My p-value is, well, you can't really see it there because it kind of goes off the screen a little bit, but it's a 0.112. There it goes. It's 0.112. Since it's so much greater than the 0.05 alpha value, we're going to reject H0. Okay? What does this mean? We've got a graph here. We've got a 6 degrees of freedom. Okay? Going out like this. We've got a chi-square value here of 10.31, right? That means underneath the curve over here, we've got 11.2% of the thing. So our H0, which said that they're all the same, the number of runners going by my house every single day are the same, is going to get rejected since we're so much greater than that 0.05. And the HA, at least one of them is different. At least one of them is different. So the question comes up, which one is different? Well, if you notice, the biggest number here is at 3.78. So Wednesday is the day where we have the most difference between our observed value and our expected value. See how this works? You can see how we're using this information. Now, let me just show you how I'm doing this calculations real quickly so that you can see it happening, okay? I'm going to clear this out. I'm going to take Thursday there. I'm going to take 9 minus 11.43. I hit enter. I square that number to get rid of the 0 or the negative number and divide by 11.43. And I get 0.51. And you can see I rounded that to 0.52. Okay? And it actually summed it all. I then summed up all those numbers to get this chi value of, where'd it go? It's on the previous screen. There it is, 10.31. Cool? I hope you understand how I did that. If you have any problems doing these type of problems, let me know. I am doing star testing this week, so you're not going to be able to catch me at home unless you do it late in the evenings. And you can send me K-mails. I'll try to respond to you. Make certain you're telling me that you're in AP Statistics because it will help me answer your questions. Talk to you later.